Hi everybody, thanks for coming back to my YouTube channel. This purpose of this video is for my calculus class. It's covering section 5.4, which are derivatives of E. Probably one of the easiest derivatives we have. As you can see right here, the derivative of e to the x is just e to the x. Now we know we're not always going to have just e to the x. We'll have e to the 2x or e to the 5x. So if you have something as e to the u, you have the exact same thing times the derivative of the exponent. And so pretty straightforward. Take a look at these two examples right here. We've got e to the 3x minus 2. So we're going to write the exact same thing. So if I have the derivative, which is y prime, I'm going to have the exact same thing, e to the 3x minus 2, and I'm going to multiply that by the derivative of 3x minus 2, which is just 3. Now usually when we rewrite this to clean it up, we'll put that 3 as a coefficient, so we'll just have 3 e to the 3x minus 2, and there's your derivative. Pretty simple. Same exact thing, derivative of the exponent. Let's take a look at one that's a little bit more tricky. Not really bad though. So y prime is going to be e to the negative 4 over x. So again, same exact thing. And then the derivative of the exponent. So I'm going to write up here a little scratch work here. Remember that I can write this as negative 4x to the negative 1. And what we're going to have there then is the derivative will be 4x to the negative 2, which is 4 over x squared. So we'll have this multiplied by 4 over x squared. Now a couple things here. Cleaning this up. It depends on what you need to do here in terms of cleaning up. A lot of times we try to say the no negative exponents. So one of the things we can do here is have 4, and then this e to the negative 4 over x would come down here as e to the positive 4 over x times x squared. That's another way you could clean that up as well. So that's one way you can do it. I'm sure there's many different, depends on what your teacher tells you about how they want it simplified or not. So I would just leave this like that so we have no negative exponents. A lot of times you'll see something just like 4 over x squared e to the 4 over x. Just leave it like that. I usually like putting my other variables and things in front of the e to the x so it doesn't get confused with the exponent. So there's some pretty simple ones right there. Let's take a look at ones that are combined with other rules. Here's one with the chain rule. And so if you remember that the chain rule is the derivative of the whole thing times the derivative of what's inside. So taking a look here, if I go with the derivative of the whole thing, that 3 will come down. We'll have e to the 2x plus e to the x, and then squared. And then times the derivative of the inside. So we have two things that are inside here. So we're going to have e to the 2x. Well, that's e to the 2x times 2 for the derivative of the exponent, and then plus e to the x. Alright, so now cleaning this up here, we've got a bunch of things going on. I'm just gonna write it as 3e to the 2x plus e to the x squared times 2e to the 2x plus e to the x. I'm actually just going to leave it just like that. Okay, so there's a chain rule example. Let's take a look here now of product rule. Alright, so now combining some of the rules again here that we have. Oh, don't need that out there. We're going to go with, remember this is our first and this is our second. Alright, so our derivative is going to be first times the derivative of the second. So if we're following, it's the same exact thing, derivative of the exponent. So I'll have 6e to the 6x. That 6 came from the derivative of 6x. So there's first times the derivative of the second plus the second, e to the 6x, times the derivative of the first, which is just 1. Alright, so now there's a couple ways we clean this one up here. So I'm okay with, in my class, 6x e to the 6x plus e to the 6x. Now the book always oversimplifies. Now you can see here they both have an e to the 6x. So you'll see a lot of times that they'll write it like this. and you'll have your derivative that way, where they factored out an e to the 6x. I'm okay with either one of these. All right, just know that on a multiple choice that one could be factored or not factored, depending upon what they have listed there. So either one of these is an okay answer. All right, so that was a product rule. So you know what's coming next. We got a quotient rule. All right, so a quotient rule here. We're looking at this. All right, we're going to have, again, now there's the bottom and there's the top. So y prime for this one is going to be bottom times the derivative of the top, which will be 3e to the 3x. Again, that 3, that's the coefficient, came from the derivative of the exponent. So bottom times derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So x squared squared would be x to the 4th. Alright, so now some things to clean up here. Alright, so y prime, I'll have this as 3x squared e to the 3x minus 2x e to the 3x all over x to the 4th. And again, this is okay, but as you notice here, hopefully, you got both terms in the numerator have an x. Alright, so we'll come back to having or taking out an x. So if we take out an x here, we'll have 3x e to the 3x minus 2 e to the 3x all over x to the 4th. And as you know, algebraically now, this cancels with one of these and gives us a cubed here. And as you can also see, they both have an e to the 3x in the top. So one of the ways I'm sure the book will have this is take out an e to the 3x, and then you'll have 3x minus 2, and this will all be over x cubed. And that would be your derivative there using the quotient rule along with e to the x. So that's a quotient rule example. Let's try one more here. We got one with natural logs. Okay. Remember a couple things here, that when you have the derivative of natural log of u, that's 1 over the inside times the derivative of the inside. So let's see if that comes into play here. First thing we probably want to do here is expand first. Alright, we want to expand this first with the quotient property. And remember here, if I got the natural log of a divided by b, that's the same as the natural log of a minus the natural log of b. So I'm going to write this as the natural log e to the x plus 4 minus the natural log of e to the x minus 2. Okay, so we've expanded there first, so that's what y is equal to. Now we're going to take the derivative. So we're going to have fractions. So e to the x plus 4 is in the bottom. The derivative of that goes in the top from that rule right there, and that's just going to be e to the x, because the derivative of a constant is 0, minus another fraction, e to the x minus 2. And we're going to have e to the x in the bottom. Now, I know, and I'm not going to do it here, that probably one way to really mess with you is to put these two fractions together with a common denominator. I'm not going to go through that. I think this is a perfectly fine answer for your derivative as well. So there's a few examples from section 5.4 of dealing with derivatives of Euler's number, E.